I wanted to talk about some really weird black holes, specifically intermediate mass black holes, which are kind of strange, right? This talk was given by someone named Patrick Truehard, who's someone who works at the North Carolina Museum of Natural History. Okay, so this is really weird. Everyone's pretty familiar with black holes like this one, like the stellar mass black holes that get formed when stars die and explode. Only really massive stars do this, not stars like our sun. But then way up here, we have supermassive black holes. Those are the ones that live in places like the centers of galaxies. We have one in the middle of our galaxy. But we're not exactly sure how they form. We're not sure if they collapsed all at once or if they formed from a bunch of black holes kind of congealing together, which means that if a bunch of black holes are kind of glomming together over time, we should be able to find these kinds of intermediate mass black holes out there. But you know, as Dr. Reitzel is going to talk about later, it's kind of really difficult to find a black hole or take a picture of it, which is why this is pretty weird. There's a pretty decent connection between how kind of spirally a galaxy is and how big the black hole in the center of it is. If the black hole, the supermassive black hole in the center of the galaxy is really, really big, it kind of winds all the arms of the spiral galaxy together more tightly. So you end up seeing these kinds of supermassive black holes up here with high mass and really tightly wound. But that's not what we're trying to find. We're trying to find these kind of loosely bound intermediate mass black holes. So the way they did this was they would look at spiral galaxies. Now, how do you figure out how spirally that is? That's kind of hard, right? So your first thought is probably put that into a computer. This is a challenge because if you just put pictures into a computer, we can find ways of processing these, but computers haven't really figured out how to take a picture of a spiral galaxy and just kind of trace it into shapes the way that, say, a human could.
We've been working on this.
If you took this picture, say, and you looked at it, you would go, spiral, right? A computer can't really do that yet, despite all of our years of trying to model it. I'm sure we'll figure it out, and this might help us. So this is where something I really enjoy comes in, citizen science. Now, sometimes there are projects that require so much filtering through information, so many images to process, that the only way to do this really is to give it to a lot of people. So in this case, they created this project on the Zooniverse website, which hosts a lot of citizen science projects. They called this one Spiralgraph. Not Spirograph, but Spiralgraph. So if you go to their website, this is what you'll be presented with. You end up with spiral galaxies, and you personally sit down and you trace out the shape of these galaxies. And eventually, you end up with these spirally shapes instead of just a picture. Now, when you take all of these and you sum them up together, you can kind of get a pretty good approximation of the spiral shape.
By sum them up, you mean by a whole bunch of people do the same galaxy?
Exactly. You can see here there are about 15 different tracings that were all added here together.
So even if someone like me gets on there and starts doing X's across the center of the galaxies,
yeah,
it averages out.
Mm-hmm. Yeah. So far, most of the people that have been working through this project are all, you know, museum volunteers and interns and that kind of thing. Or you could go online and do this. I tried this out myself. But here's the great thing. You take this weird tracee that is the sum of everybody else's drawings, and then you put it through a computer. And then that computer can go, oh my gosh, this is about this much spirally. And then we can pop out these intermediate mass black holes. Now, that's pretty incredible. We can use the power of all of us together to find things that were really impossible for a computer to do. And then once you do enough of these, you can take that information and then you can feed it into computer programs to allow them to better be able to do this themselves, which means that if we work together, we can actually create programs that can do it for us so we don't have to go through the trouble. So far, there are only 90 volunteers, but they've managed to classify over 4,000 of these objects. They're not sure yet if they've found an intermediate mass black holes because you have to follow up with observations afterward. So they're trying to figure out candidates, and then they're going to point telescopes at them and kind of look at them and go, I think that's a black hole, which is super exciting. So I really encourage you guys to go online and check this out. Or if you don't want to look at specifically spirally shapes, they have tons of projects online, not just astronomy related, but you can do biology, you can do things to help the world, and together we can do some science. So yeah, go ahead and do it.
Sarah?
Yeah, thanks.